Welcome everybody to Amphenol's webinar on key products for the Open Compute project community. We will go through the presentation today with our three presenters. At the end of the presentation, you can type a question in the question section, or you can raise your hand and I will open up your audio. Go ahead, Carmelo.
Hello, everyone. Good morning and good afternoon. My name is Carmelo Cruz. I'm the Product Marketing Manager for our Power Solutions business unit here at Amphenol. And today I'll be providing a product overview for our product technology as it relates to the OCP ORV3 product offering and specifications. So as a quick agenda, the following specs I'll be reviewing in a little bit more detail, starting with the ORV3 Power Shelf Universal Input Connector, which relates to the AC input connections into the PSU shelves. This includes the AC input connectors inside the PSUs, and then also the AC whip cable assemblies, which is the input from the facility. The next spec is the IT gear input connector, which was specified for the IT gear server storage and switch equipment. And then the last rack and power specification is the ORV3 power, which was designed specifically for the PSU and BBU shelves or battery backup shelves. And then the next set of specifications that I'll talk a little bit about is the OCP MCRPS specs, which are fairly new for our power solutions. We spent the last 6 months designing some new 48 volt and high voltage cable assemblies, and in addition, a new card edge connector. And then lastly, I'll talk a little bit about our contributions to the Advanced Cooling Solutions group and some of the subcommittees that we're involved in. We've provided some valuable data as it relates to our BK150 and BK500 and immersion testing conditions. So the Amphenol Power business unit has spent the last 3 years designing and collaborating with the OCP community to come up with a subset of power distribution solutions within the OCP rack and power space, and then also at a system level specifications. So one of the first ones is the bar clip BK500, which again was designed for the PSU and BBU connectors. I'll talk a little bit about these in depth today. The next one is the bar clip BK150, which again is the IT gear connector for the power input into the servers, the storage systems, and the switches. The next one is our PowerBlade Ultra, which was the interconnect designed for the PSU and BBU interconnect level power distribution. Our PowerBlade family has been in the industry roughly 25 years and has been a de facto standard and PSU and BBU connector power distribution selections. And then the last two connectors is the AC whip cable assemblies, which I'll talk about here at the end of my presentation, and our Cool Power SDM, which is our pin and socket offering for inside the box power distribution. Before we jump into the system or the component level specifications, I wanted to provide a high level overview of what's changed from a rack power distribution level between ORV2 and ORV3 racks. There's 3 primary differences at a rack level. So the first one being on the ORV2 12 volt rack, we had a fixed or vaulted power distribution shelf onto the bus bar, whereas on the 48 volt rack, we've now connectorized those shelves. The second one, on the ORV2, we had a combined PSU and BBU sleds, whereas on the ORV3 rack, we now have individual sleds. And then the last difference is the two power zone 12 volt output on the ORV2 spec, whereas now we have a 1 power zone 48 volt output on the ORV3 spec. One of the key benefits to connectorizing and separating the PSU and BBU, it now provides customers the flexibility or modularity within their system designs to move those PSU shelves or BBU shelves up and down the rack as needed, or even add PSUs and BBUs for additional power density for emergent applications such as AI. Here's a quick diagram flow of the power distribution into the PSU shelf. So very simply, we have the AC input power from the facility that flows into the power shelf, which is then converted from AC to DC via the PSUs. That power is then to the output connector or our Bartlett BK500 onto the bus bar and distributed down to the battery backup units and the IT gear shelves through via the BK150s. As I mentioned on the previous slides, we spent a lot of time developing some of this next generation power distribution assemblies, which is going to enable some of the higher density applications that we'll see here within the next 2 to 3 years. So I'll talk a little bit in depth about the changes to the BK150, the BK500, and then most recently, we've released our BK600, which is an upgrade to the BK500 within a 2U space, but also specified to the same criteria and specifications as the BK500. So I'll first start with the BK150. The BK150 is the IT gear connector spec rated at 48 volts. This connector is rated up to 150 amps load and return, so we did increase the power density from ORV2 from 100 to 150 amps. This 150 amps is rated in still air. We've also added additional chassis ground contacts. These contacts ground the chassis to the rack and are rated up to 64 amps for up to 2 minutes, which is double the current of the AC input connector, or 32 amps per contact per the OCP specification. The next change is we've added new sense contacts for mate last, break first capability or hot swap capability. This is to be used in conjunction with the hot swap technology within your system to avoid any damage when unmating from the bus bar or damage to the contacts. The last change we've made is we've added some additional float capability on the horizontal axis to plus or minus 3 millimeters versus the 2 millimeters that we've had on the ORV2 spec. In the beginning, I've also mentioned that we've done quite a bit of work with some of the immersion cooling committees within OCP. This has been done by our thermal team led by Guangli Chen within our business unit. And we've conducted some immersion testing to compare against the baseline, which is the still air in the spec. And as you can see in the immersed cooling, the static cooling environment, we've seen quite a significant increase in power density, up to 132%, essentially doubling the current in an immersed test environment versus a still air test. And then lastly, for the BK150, we've introduced a bunch of different flavors into the market as far as capabilities go and mounting options. So the standard is the straight exit, which requires hardware to mount to the panel. We also have a slide to lock version, which is a toolless version that can be slid into the panel opening and locked with our locking feature. And then we have multiple exits or cable exit options for different cable routing within the systems or to route around space limitations within the servers. The next connector is the BK500IO. This connector is rated for 360 amps load and return in still air. And then we've also have an airflow rating, which is the 45 degrees C and 300 LFM for 500 amps load and return. This is the OCP spec. This connector also features a chassis ground contacts for 64 amps up to 2 minutes, very similar to the BK150. And we do not have sense contacts designed into this connector due to safety concerns, and something that we don't recommend doing given the high voltage and the high amperage within the connector system. We've also conducted some additional immersion testing and some additional airflow testing with the BK500. So again, the spec is 300 LFM within the OCP community. We've added some additional airflow testing at 400 LFM and then also conducted immersion cooling. You can see with the 400 LFM, we've achieved up to a 78% increase in density. And then in the immersion environment, almost a 200% increase or improvement almost doubling the current capacity from 500 amps to over 1,000. This is pretty impressive test results, and we're really excited about the future of immersion cooling and what technology we can enable with our solutions in immersed situations. And then the last connector, as I mentioned, this is an upgrade path to the BK500. This BK600 is not in the OCP specifications, but was designed and tested to the same parameters and test criteria as the BK500. This connector is rated for 450 amps load and return in still air. And we've also increased the density, 45 degrees C, 300 LFM to 700 amps load and return, which again follows the same OCP spec as the 500. This connector system is ideal for two-use systems and for applications looking for higher density. Next, I'll talk a little bit about our AC input connector and cable assemblies. So we do have quite a bit of different configurations in the AC input space. These components or connectors are amps per pin per the OCP specifications. They're designed in a 7-pin configuration, designed for star, delta, and single phase connections. They're fully compliant with the ORV3 power shelves. And we also have NEMA and IEC cable options, which I'll share here in a few slides. Just to point out a few of the features, again, this is a 32 amp rated connector and 600 volts AC/DC. We have hard shell and back shell overmolded options. We offer multiple termination styles, which I'll talk about in another slide. Some of the features have polarization and touch-proof features, and then we have different wire gauge options as well. Here are some of the different flavors that we offer as far as termination options. So we have PCB mounted, both in right angle and vertical terminations. We have crimp termination styles, and then we also have a hybrid with both PCB and crimp termination. And then for the whip side, the input cable side, we have a hard shell clamp or clamshell version, and then also overmolded versions. These versions come in both 45 degree straight exit and top exit cable exits. Here's just a quick look of our AC whip options. These come in both IEC and NEMA, are very customizable in length and size of wire gauges. These are both in mass production and available to the OCP market today. As far as our product roadmap for the AC input, we also plan to release a 60 amp universal AC input, which essentially follows some of the same OCP specifications today. This will be targeted towards 2OU applications for higher density, and we plan to offer the same component modularity and configurations as the existing 32 amp spec. And then lastly, I'll talk a little bit about our MCRPS standard DC input solutions. This solution was designed specifically to enable retrofitting existing rack level components into an OCP rack ecosystem. This connector system is rated up to 40 amps per pin using 8 gauge wires and comes in both crimp and PCB mounted pins with some overmolding options. This connector is tooled and available in the market today. And then last, we've introduced, as part of the MCRPS spec, is a high voltage version, which is rated up to 30 amps with 10 gauge wires, has touch-proof features on both the header and the receptacle side, and easy squeeze to release latching for unmating. With that said, I'll be passing on the presentation to Zifan.
Thank you, Camaro. So I'm Zineng Fan. I'm a technologist from Amphenol. I'm a committee rep sitting in several committees for Amphenol. So today I'm going to share our SSIO product that for OCP applications. First one is a mini core edge. Our mini core edge connector follows the SFF TA PA1002 standard. So the form factor and the interface all follow the standard compliance. They come different configurations with different orientation. So here we give a little bit of map to show the overall our product line profile. And among those products, you can see several committees adopt those products for their applications. Gen Z, EDSFF for the SSD application, and the JEDEC for memory application, and the OCP uses this type connectors for all kinds of applications like OCP NIC and SCM and other modular applications as well. So for the vertical connector, we have standard tooled up with the 1C, 2C, 4C, and 4C plus pin configuration. And we also have non-standard, means not specified in the SFF TA102. Those pin configurations like 48 pin, 196, and 224 pins. And also recently we have offering for the thicker IC card that is 2.36 millimeter. Mainly is for the requirement coming from the OCP OII application. And on the right angle connector, we have 3.05 and 4.05 standard seating height. And we also offer the higher seating height, like a 705 and 720 millimeter, to give more clear space beneath the module, so you can fit in high, taller components underneath there. And for OCP NIC and DC-SCM applications, they mainly specify the straddle mount type connectors for the application. And certainly we have all the standard version tooled up, and we also offer some non-standard straddle mount connectors, mainly for the different host side board thickness, like 2.11, 2.2 millimeter, and 2.5, and up to 3 millimeter as well. And those connectors also be used in the DC-MHS for the HPM board. So each HPM board specified one OCP NIC and one DC-SCM. So this is the straddle mount connector, and for the EDSFF SSD application, mainly the E1 wise, there's a vertical and a right angle connector you can use. You also can use the orthogonal connector. There's two type of orthogonal connectors we told us. One is a wiper type, and one is a PCB two pieces type. So the PCB pedal card type gives some flexibility on the offset between the host board and the SSD card, and orthogonal wise give more robust and neat solution. So depends on the application you can choose. For E3 SSD application, then the interface wise, although compatible to the SFF TA102, it lift up. So the electrical path between the interface to the baseboard is a little bit long. So for the applications for the Gen 5 and Gen 6, we think it's make more sense to develop the cable version. So here is the cable type connection we developed for the E.3 application. So in the cable wise, you don't need to go the electrical don't need to go around the PCB. That is more loss than cable, and you don't need to go around the second side pans. You can go around the baseball for saving the cable, or you certainly can also put it in the cable as well. So this is give flexibility of the E3 application. And to increase the density, we look at the different approach. For certainly scale the pitch is the easy way, but when you get the smaller pitch, you may sacrifice other properties. So for that, we keep the 0.8 millimeter pitch for this double density connector, and introduce the 2-row contact on the each side. So therefore, you actually achieve the effective 0.4 millimeter pitch in your application. So this connector can go up to 428 pins, and very ideal for application like you want to break out from this connector to 3 cam connect by 3 by 16 cam connect. And for the cam connector, certainly we very closely follow the PCIe SIG development, and we have the Gen 5 and the Gen 6 tooled up. And for the Gen 7 PCIe currently doing the path finding work, we also provided some early development data for the committees to study with their channel performance. Besides the standard offering, we also have some tweak on the connector. So here is showing is compared to the standard the solid lead fan out. We also have the flop on one side, like J type and L type solid tail. So it's good for the application, like place the connector on the edge of the board, and you don't have the way to route from another side. So you can route everything from single direction. And same reason, you know, the PCB loss is high. And if you look at the typical PCIe topology, there's a PCB between the root complex and the connector. So that length is pretty long, and if you use the PCB material, and you have to use the low loss material to achieve higher performance. And for that, it may make more sense to save the cost for low loss PCB and introduce the cable connection here. So on the CAM cable wise, you still have the CAM interface. So you can plug in the Gen 4, Gen 3, the previous generation CAM card to the this CAM cable connection. And also you have the cable to save your loss, and place the like MCIO connector to close to your chipset. And to further improve the performance, we also developed the direct attach, means instead of has a small PCB to land the CAM connector, we land the cable directly to the CAM connector contact. So therefore, you save the loss in the PCB pedal card side as well. So this is a high performance cable solution we are developed for the Gen 6. And another customized offering deviate from standard CAM connector is we call the core edge 1 millimeter pitch. So that one comes with a slim body, So you save the PCB surface like by 30%. And we also have the speed up to the Gen 5 offering here. So for the memory application, so DDR5 memory already launched in mass production. And we also look at different options on improve the DDR socket. And one concept showing here is we are trying to explore whether we can shrink the connector and squeeze more memory module in the same border space. And other tweaks on connector like metal clip that is enhance the mechanical strength of latch. So for the application, you have multiple actuation, latch actuation case. This will help you. And also one challenge in the DDR application is how to cool down the DDR module. So the airflow is important to cool down the module, and we can help from our connector side is to narrow down the latch. So this is a narrow latch offering, can clear the pathway, so you have more airflow. So this is a help a little bit on the thermal side. So on the also, if you have limited space and you place the module side by side, you may not be able to open the one side of latch in this case. So we offer the single latch connector option. So one side of the latch is fixed, and the other side you can operate that to actuate the module. There's one new development from JEDEC. So recently, the JEDEC committee found out there's IFU pin in the connector that impact SI performance at the high frequency. So that could impact like the MRDD application. They recently released the new SO to remove the pin 220. So therefore, we are following that to produce this new connector. So this is a 287 pin connector to help that issue. DDR certainly used in the CXL application, like the CAM form factor. So you have the CAM module on the, you have the DDR module on the CAM card and plug into the CAM connector for CXL application. And the JEDEC also has another type of form factor developed that actually follows EDSFF SSD. So it's same size as the EDF SSD. You can plug into the same slot, but the inside they change switch to the SSD to the memory module. So that is another application for the CXL. And the interface certainly is our mini core edge connector compatible. So for the M.2 side, we have two new updates to the connector. One is speed-wise, we upgraded to Gen 5. And another one is we follow the PCIe SIG development and implemented 1 amp per pin. So increase the power delivery compared to the previous version is 0.5 amp per pin. And besides the standard M.2 offering, we also to connect for different applications. So this is the kind of illustration of how we did for the Gen 4 type. And we have the vertical type 12, and that helps some application if you want card insert perpendicular to your baseboard. And we have the orthogonal type as well. And some applications not typical M.2 usage, and you want to expand the pin count. So we have 125 pin, 134 pin over here. And for the EMI sensitive application, we also can put metal shielding around the connector to help that. And another case is if you want to have more clearance beneath the M.2 module, we have the taller connectors than the 4.2 standard one. And we also offer the stacked M.2. So you have two M.2 module on the one on the top to save the space. So for the SSD applications, EDSFF is new, become more and more popular. But the U.2 still there for a lot of applications. U.2 is still advancing technology, and currently we get the PCIe Gen 5 speed for the U.2. And also at the same time, we are looking at the SAS5 application as well. And look at the SI performance. Here we show the compliance to the PCI SIG 5.0 SI mask. And we have every SI parameters pass the spec and with good margin here. We also look forward the Gen 6 U.2 application, and it's very early kind of development. And we did some early study to show what the performance we can achieve. So this is the SI performance we show here with PCIe CAM 6.0 mask plotted. And because there's certainly, there's no Gen 6 U.2 SI mask yet. So this is kind of for the reference. So we use the CAM 6.0. And if you are interested in the Gen 6 development, we would like to work together to see what is the real requirement for the Gen 6. And this concludes the SSIO product. And now I will hand over to Tim to talk about the cable side.
Hello, everyone. My name is Tim Pack. I'm one of the FAEs supporting the design work that relates to OCP DC-MHS. So there are 6 specs in DC-MHS, and I will be focusing on 2 specs that discuss HPM types. Those are M-FLW and M-DNO. So just in case you are not familiar with HPM acronym, HPM stands for Host Processor Module, also known as a system board, motherboard, or baseboard. So I will be discussing 4 HPM today and what products Amphenol support for each HPM type. The first HPM is M-FLW. It is a full rack HPM. On this slide, I want to give you a brief overview of what products Amphenol supports. I will also deep dive into some connectors and show you more details in the later slides. Number 1 is Multi-Trak. DC-MHS allows up to 6 multi-tracks to be placed on the full width HPM. Number 2 is the MCIO. MCIO is to be used in the far end I/O connector zone for connecting the front storage drives to HPM. Number 3 is USB Type A, Type C. Although this picture shows the Type A, but we support both USB Type A and Type C for internal host application. For example, control panel expansion. Sometimes people may use it for debug purposes. Number 4 is a kickstart. Kickstart is used for cable optimized boot peripheral connector. It's connected to system boot drive. Number 5 is 2x10 header. It's a 20-pin header. It is used for connecting between the HPM to the left or HPM to the right control panel of a server. So to summarize, so there are 5 products we Amphenol offer: Multi-Trak, MCIO, USB Type A, Type C, Kickstart, and 2x10 header. Next, I want to talk about the MCIO. MCIO is one of the industry standard connectors, and it has a SFF number 1016. Both PCIe SIG and DC-MHS adopt the MCIO for internal cabling solution. Industry standard connector enable multi-sourcing. It is really important for customer because customer can select different vendors to be your suppliers. So this is a table that shows you all the configuration that Amphenol offer for MCIO. MCIO, we have a vertical, right angle. We have different pin counts from 38 pin all the way up to 148 pins, and we can also provide you the drawing 3D model, and all configuration on this slide are 2 up. Okay. So MCIO, there's a roadmap for MCIO to Gen 6. The existing MCIO shipping version is Gen 5, but we do have a roadmap for Gen 6. And some of the configuration are 2 up or in the medium of tooling. But you can see different configuration are on the roadmap. So this is a slide to show you the comparison between MCIO Gen 5 and MCIO for PCIe Gen 6. They have identical footprint, identical interface, and identical dimension. They're all the same. The only difference is the internal. We modified the internal design to make it more SI robust that will support a PCIe Gen 6 application. So because they are all the same, they look the same, we implemented, we put a laser mark. This is just one of the features that we put on the connector for PCIe Gen 6 that will allow user easily identify this connector you are using is for PCIe Gen 6. But this is, we have a couple more mechanical features for user visualize, easy for user to visualize the difference. Multi-Trak. Multi-Trak is also the industry standard connector. It has a SFF number 133. Multi-Trak is also adopted by DC-MHS. So it is important for customers that have different vendors to be their suppliers. So this is the Multi-Trak. Multi-Trak is designed for PCIe Gen 5. It has a roadmap for upgrading to Gen 6 as well. Multi-Trak Gen 5 and Gen 6 version share identical footprint, identical interface, identical mechanical dimensions. So inside the receptacle is modified. The next generation the next version we modify for PCIe Gen 6 application. There are 3 sections in Multi-Trak. The first is power section, support application that require power or current up to 21 amps at 12 volts. The second section is the sideband section, support 12 low-speed signals. The third is the high-speed section, support either 1x16 cable application or 2x8 cable application. I will discuss different cable application in the later slide with pictures. So this is the summary table to show all multi-track configuration. 3 configurations are included in SFF 1033. The first one is power plus by 16 application. The second one included in SFF 1033 is power plus by 8 application. The third one is power only application. And there are 2 other configurations that are not included in SFF 1033 for application that require higher power, more current, up to 55 amps. This slide shows you how multi-track can be used. The first application is the add-in card application or AIC application. The second application is a multi-track can be used as combo solution where power, low speed, high speed are all in one cable assembly. The combo solution supports both right angle cable assembly and reverse right angle cable assembly. So board designer, do not worry about how cable assembly routed in the system when designing the board layout. So the engineer can just pick the multi-track connector, put down on the board, put down on the PCB, and worry about the cable routing later. That gives you a great flexibility. Multi-track can also be used with 2 standard MCIO by 8 application, where you can mix with vertical, right angle, reverse right angle cable assembly in one single connector, depending on your application. So multi-track offers the greatest flexibility for your system design. Next, I'm going to talk about M-DNO Type 2. The previous HPM was full rack width HPM. This is called Type 2 HPM. Type 2 HPM, we do offer 2x10 header. Number 2, MCIO receptacle. Number 3, USB Type A or Type C. Number 4, kickstart. Number 5, multi-track. And number 6, intrusion switch. The next one is M-DNO Type 3 and Type 4 HPM. They are very similar. The difference is just the dimension of the HPM. But as far as the location of the connectors, they are very similar. We do offer 2x10 header, MCIO receptacle, USB connector, kickstart, multi-track, intrusion switch as well. Just want to give you a summary slide to summarize all the contents. of this section. This is a summary slide. So for no matter full width HPM, Type 2, Type 3, Type 4 HPM, these are the connectors we do support. So thank you. I'm giving back the time to Laurie.
Yep, I will open it up now for any questions. I have one question for Carmelo. When is the 60 amp universal AC input connector option being released?
Yes, the 60 amp AC input solution has already been designed and will be, we're looking to have first samples off the tool by the end of the quarter, end of Q2, which is roughly the end of June.
I'm just going to look to see if anyone raised their hand. And question, what liquid is being used for immersion cooling with the BK connector?
That's a good question. Well, there's a lot of fluids out there. I believe our testing has been completed in a single phase fluid, which is the shell. I don't have the specific type, but I know it was a shell liquid used, or shell fluid used for the testing we've completed with the bar clip connectors.
Okay. There was a question about the presentation. Presentation will be available after this is finished, and we will have it sent to everybody who participated today. Where can we see the products in person next? I would say, Carmelo, probably at OCP.
Correct, yeah. The next showing on a mass scale for a show will be at the OCP show, and by then we should have a lot more of these next gen technologies that we mentioned today, the 60 amp AC input, also the MCRPS solutions that are available now that the market as a whole hasn't seen. But I would say yes, OCP, and the samples are also available via sample as well.
And Tim, question is Kickstart connector a spec?
Yes, the Kickstart connector has a SFF number. I think it's 1036. So you can go to SFF website, download that spec.
Okay, thank you everyone for attending. If you have any additional questions, you can go to our website or you can contact me directly. Thank you for participating in this webinar.